we have a question that why does breaking down, just a second. So, why does breaking down, okay, why does breaking down ATP to ADP release 30.5 kilojoules of energy? From ADP, when we go to AMP, that also releases 30.5 kilojoules of energy. But when we break down adenosine monophosphate, so AMP, we just have one phosphate, and when we take that last phosphate out, it releases only 14.7 or 14.2 kilojoules of energy. Yes, so 14.2 kilojoules of energy. Why is that? So, it's not that simple. Like, okay, if you need just a really simplified explanation of how does ATP give us energy, you just say ATP to ADP 30.5 kilojoule, ADP to AMP 30.5 kilojoule, AMP to adenosine 14.2 kilojoule. You just memorize that and that's it. But if you really want to understand the concept of why that is, we need to delve a little bit into the biochemistry of this reaction. Okay, so what happens is energy, this adenosine monophosphate, it's not just being like, we're not just taking out this phosphate and okay, we got energy. No, it's not that simple. What we are doing is, first what we need to do is give this bond right here, so this one, this bond, what we need to do is give it, for example, 20 kilojoules of energy. Okay, the numbers don't really matter right now, you just need to learn the concept. Okay, so first we have to give it some energy. Okay, now when we give it this energy, this bond is broken. Okay, but the thing that happens now is that as soon as this bond is broken, now we get this energy. So this bond, after it's broken down, it releases, for example, 50 kilojoules of energy. So we gave it 20 kilojoules and now we got back 50 kilojoules. So we have a net energy gain of 30 kilojoules. The numbers don't really matter. Okay, now why does this molecule give us 50 kilojoules of energy? Like, that's a really big amount. The thing is, like, we have a negative charge here. Okay, if we have a negative charge here, this whole molecule is negatively charged. Yeah, this one is also negatively charged because of this. So this one is negatively charged, this second one is negatively charged, and this third one is also negatively charged overall because we have a negative sign. Okay, now all of these negative charges, they are jam packed really close together. Okay, and they don't really want to be here. This one, this third one, is repelling the second one to just get away, to move away from here. Okay, the second one is repelling the first one to just get removed from here, just go away. Okay, this, like, this repulsion, this is the reason why we have a huge amount of energy released when this first one is taken out. Okay, now in the second one, the same thing happens. We give this bond, so this bond right here, we give this bond 20 kilojoules of energy. Okay, and as soon as the second one is removed, we get 50 kilojoules of energy back, a net of 30 kilojoules. Okay, but now when we have removed all of these, okay, so this one is removed, this one is removed, now we have just one phosphate. But look here, we have no negative charges here, no negative charges here, nothing over here. So this phosphate, this doesn't really want to go out. But if we still want to remove it, what will happen? We will give this bond 20 kilojoules of energy, and what will it give back? 34 kilojoules. Not like here where we get 50 kilojoules. Okay, so now we have a net of 14 kilojoules of energy that is given back to us. So the main idea is that this last one doesn't want to leave this molecule because there is no repulsion, it's happy here. Why are you removing it? But if you still want to remove it, we will just get 14 kilojoules. Okay, that's like the first part. So the first reason might be that the repulsions between the phosphates help the removal. Okay, but at the last one we have no repulsions, so we do not, like, this one wants to stays here, but if we still remove it, it's not happy, and it just gives us this little bit of energy, not like the maximum 50 kilojoules. Okay, the second reason is that this is a different bond. Okay, what do I mean by that? So let's just take this image. We are taking this molecule and we are taking this molecule. Okay, the bond that you see here, this one, this is between an oxygen and a phosphate. Okay, and if we break down that bond, we will get 30.5 kilojoules of energy. Same thing here, we have an oxygen and we have a phosphate. If we break down this bond, we will get 30.5 kilojoules of energy. But look here, we have an oxygen, but here we have a carbon. Breaking down the oxygen carbon bond only gives us 14.2 kilojoules of energy. Okay, so at first we will break down oxygen phosphate bonds, but now we are breaking down an oxygen carbon bond, which is a different bond and it has the different energy. Okay, I hope that made sense, and I'll see you in the next one.